Welcome to NPA Infracon YouTube channel, your destination for quality civil engineering education videos. In today's session, we will discuss the advantages of using thermoplastic piping products over traditional metal piping materials. It highlights features such as ease of handling, flexibility, a variety of joining methods, excellent hydraulics, and lower life cycle costs. The document also mentions the limitations of thermoplastics, particularly their low strength and sensitivity to high temperatures. Additionally, it provides information on the properties and applications of polypropylene, PP, and PVC pipes, as well as guidelines for installing and backfilling pipes. Furthermore, it introduces Vinidex StormPRO pipes for stormwater applications. It features an installation process of StormPRO twin-walled corrugated polypropylene pipes for non-pressure drainage and stormwater applications. It covers aspects such as pipe stacking, trench installation, bedding zones, jointing methods, connection to structures, and backfilling. The importance of proper installation techniques, including using the correct embedment material, ensuring proper pipe alignment, and following specific guidelines for different pipe sizes. Additionally, the process for making connections to StormPRO pipes using Vinidex programlets and Pro saddles, as well as the importance of side support for pipe integrity. Overall, the video aims to provide comprehensive guidance on the correct installation of StormPRO pipes for various applications. Stay tuned for an engaging and informative session. Thermoplastic piping products are cost-effective solutions to a variety of piping applications and offer many advantages when compared to traditional metal piping materials. Some of these features, which have spurred the widespread acceptance of plastic piping materials for many applications, are ease of handling. Plastic piping materials are much lighter than most other piping materials and therefore do not require heavy handling equipment. Cutting, joining, and installing plastic piping is far simpler than the same procedures for other materials. At today's labor rates, the increased productivity is vital to the cost of the overall piping system. Flexibility and toughness. Most thermoplastic piping materials are flexible, which is an important characteristic for underground applications. The pipe can follow natural contours and transitions around obstacles, which reduces the number of fittings required in most piping applications. Because of their excellent flexibility characteristics, plastic piping materials work well in harsh climate conditions. Variety of joining methods. Many joining methods are available for plastic pipe. It can be threaded, flanged, cemented, heat-fused, and compression-fitted. The many joining methods make plastic pipe adaptable to most field applications. Excellent hydraulics. Plastic piping materials provide a smooth pipe wall and have low resistance to flow. They also have a high resistance to scale or buildup. Lower life cycle cost. Plastic pipe has excellent corrosion resistance and provides a system with a long life. This and other cost benefits make plastic pipe an attractive economic choice. Long life. The service life of any piping material is important. Millions of plastic piping installations have been in service for more than a quarter of a century and still are functioning well. In most conditions, there is no end of life of a plastic piping system. Standards. Standards have been developed for many plastic piping materials. Regardless of the manufacturer, these standards make sure that plastic piping products have uniform characteristics. Easy identification. Plastic piping is marked to aid in identification. Manufacturers mark and test their pipes and fittings according to ISO standards. Limitations. The primary limitations of thermoplastics come from their relatively low strength and stiffness and their sensitivity to high temperature. Because of these limitations, thermoplastic piping materials have been used mainly in low-pressure applications with low temperature limits. Even with these restrictions, thermoplastic piping materials meet the design requirements for a wide range of applications. Polypropylene, PP, is an economical material that offers a combination of outstanding physical, chemical, mechanical, thermal, and electrical properties not found in other thermoplastics. Compared to low or high-density PE, PP has a lower impact strength but superior working temperature and tensile strength. PP is a tough, heat-resistant, semi-rigid material that is ideal for the transfer of hot liquids or gases. Polypropylene-based piping is also the lightest weight plastic material and generally has better chemical resistance than other plastics. PP is used in some pressure piping applications, but its primary use is in low-pressure lines. Polypropylene plastic pipe is used for chemical, usually acid waste drainage systems, natural gas and oil field systems, and water lines. The maximum temperature for non-pressure piping is 90 degrees centigrade. Pipe lengths are joined by heat fusion, threading, i.e. with heavy pipe and mechanical seal devices. With ultraviolet UV stabilization, PP piping material provides good long-term service in outdoors applications. The ability of the PP material to withstand weathering depends on the type of UV stabilization and the amount of UV exposure. As per ASTM test, mechanical property of rigid PVC pipe are tensile strength 6,000 to 8,000 psi, flexural modulus of 300,000 to 800,000 psi. While unmodified resin PP pipe has tensile strength 5,000 psi, flexural modulus of 200,000 psi to 300,000 psi. Once a pipe is installed in a trench and is ready for backfilling, it is a good idea to put some pressure in the pipeline. A pressure of just 25 psi can help in keeping a pipe from collapsing during the backfilling process. The first layer of backfill material shouldn't be more than about 0.3 in depth. Get this layer in the trench and compact it to protect the pipe as more backfilling is done. Many times, the trench will continue to be covered with similar layers of backfill that will be compacted before new layers are added. Compaction shall be carried out using lightweight plate compactor up to the depth of 300 millimeters. Compaction using the weight excess to 2 tons shall be applicable after reaching compacted layers depth exceeding 0.3 years. Compaction using the weight excess of 4 tons shall be applicable after reaching compacted layers depth exceeding 0.6 m. PP pipe are advisable to use in trafficable area. Vinidex StormPRO pipes are used for stormwater applications. StormPRO has a black-colored corrugated outside surface and a smooth light gray interior. Each length of StormPRO pipe is supplied with the rubber rings required for jointing. StormPRO pipe is available in standard rubber ring jointed spigot socket configuration SPSO and comes in 3 meter and 6 meter as standard lengths. Visit the Vinidex StormPRO pipe product catalog at N264.stormo product catalog PDF, vinidex.com.
StormPRO pipes are twin-walled corrugated polypropylene pipes for non-pressure drainage and stormwater applications. These applications include road, rail, land and housing development, mining and rural applications. StormPRO pipes are relatively lightweight, robust and can be used in any site conditions. Smaller sizes can be lifted manually. Pre-inspection needs to happen for all pipes before installation. StormPRO pipes should be stacked on flat, firm ground, which has been cleared of debris and hazardous combustible vegetation. Pipes should be laid flat on transverse bearers at least 75 millimeters wide at maximum 1.5 meter centers. Pipes can also be stored nested for long periods. Pipe sockets should be supported so that the ends are free from loading. Different sizes are best stacked separately. There are many advantages of flexible pipe, such as strength, flexibility, crack resistance, easy installation, and tough, to name a few. The 4 main parts of the trench installation are 1. The bedding zone, prior to pipe installation and house connections. 2. Side support zone. 3. Overlay zone. 4. And the trench fill zone. Trench work should be as narrow as practical. Health and safety are imperative with all trench work, so please manage the risks associated with any trench work. Using crushed rock, sand or other compactable material, add a layer of this material to trench floor. The layer of bedding will need to be level, as per grade required, and compacted to support the base of the pipe. Small indentations should be excavated to accommodate the pipe sockets so that the pipe is uniformly supported. A laser level is the preferred method to achieve optimal fall and grade. A compactor is recommended to be used to ensure good compaction of the bedding zone. Installation takes place after bedding zone preparation. Pipe sizes DN150 to DN600 can be easily cut anywhere along the pipe length, and the same socket system can be used. DN750 and DN900 pipes have a geometrically different spigot end, so if they need to be cut to length, couplings may be required for jointing. Cutting through PP compared to concrete pipe is significantly easier. All connections to structures, houses and other fittings should be installed after the bedding zone and prior to site support backfill. When it comes to jointing, StormPRO pipes have a simple and effective rubber ring joint system, which is easy to assemble, watertight and protects against tree root intrusion. Please be aware of the correct rubber ring configuration, dependent on the pipe size. For pipe sizes DN150 to DN600, install the rubber ring by stretching it over the spigot so that it sits between the first and second corrugations from pipe spigot end. DN750 and DN900 pipes, install 2 rubber rings, one in the valley between the first and second corrugations, and one in the adjacent valley between the second and third corrugations from the spigot end. Ensure rubber rings are evenly fitted by running fingers around the full circumference of the pipe. Apply a generous quantity of Vinidex jointing lubricant to the inside of the receiving socket. Avoid getting lubricant under the rubber ring valley, as that can introduce contaminants to the joint or become displaced during jointing. Insert the leading edge of the spigot into the receiving socket. It is essential that pipes are in a straight line before attempting to make the joint. Double check that the ring and spigot are free from any grit. Do not apply jointing force directly to the socket. Insert a short stub of pipe into the socket. The short stub can be an offcut, 50 mm longer than the socket, and can be reused. Additionally, you can screw a piece of timber across the face to assist with force. A rubber ring is not to be used on the insertion stub. Push the pipe home until the spigot end comes into contact with the inner wall of the socket. A leverage tool, such as a crowbar, is generally sufficient for StormPRO pipes up to 375 mm nominal diameter. Where applying a jointing force is not practical, consideration should be given to the use of come-along or winch and rope devices. Other mechanical methods may also be used, such as pushing the pipe together with a bucket head for larger sizes. However, caution should be taken for all methods to ensure the socket end is protected by using a short cut-off stub insert. Please note, the jointing force required increases with the nominal diameter of the pipe, allowing for adequate fall as per velocity and discharge tables in the Vinidex StormPRO catalogue or as recommended by consultant engineers. StormPRO pipes may generally be connected to rigid structures, such as pits, head walls and end walls, both precast and cast in situ. This image shows a typical entry or exit to a concrete structure. As you start from the pit entry, the spigot will always be the first point to connect, with the installation of the pipe usually going upstream. Vinidex has 2 systems for making stormwater connections to StormPRO pipes, programlets and Pro saddles. The Vinidex Grommet range of stormwater service connections provide 100 mm and 150 mm diameter connections to StormPRO pipe up to 900 mm nominal diameter. How to install the Grommet? 1. Drill a hole in the StormPRO pipe using the Pro saw. The hole center must be located in the valley between corrugations. 2. Use a 127 mm hole saw for 100 mm connections or 177 mm for 150 house connections. Please note the new 177 mm hole saw only works on pipe 300 mm, 375 mm and 450 mm. 3. Inspect marking on Grommet to ensure the correct size for selected StormPRO pipe. 4. Present Grommet to hole with Grommet flange to the inside and locating wings to the outside of the StormPRO pipe. 5. Squash the Grommet by hand so the 2 locating wings align in the center. 6. With the flattened Grommet, form a C shape and offer it to the prepared hole. 7. Position locating wings in the valley of the StormPRO pipe profile. 8. Apply Vinidex lubricant to the inside diameter of the Grommet. 9. Insert spigot and socket PVC connection. This connection piece eliminates pipe creep into the system and should always be applied. 10. Attach applicable pipe size to grommet attachment and solvent weld. 11. Now the connection is ready to be buried. How to install the Pro saddle. Follow steps 1 and 2 of Pro Grommet installations. 3. Inspect marking on Pro saddle to ensure the correct size for selected StormPRO pipe. 4. Remove cable ties holding flange on saddle. 5. Place flange over the hole saw area, positioning the predetermined holes over the top of the corrugation. 6. Place PVC saddle over flange without moving flange position. 7. Screw the hex screws through the allocated holes. 8. Replace cap or connect pipe as per normal procedure. Side support is an important next step after the pipe preparation and jointing. Embedment material for StormPRO pipes should preferably be granular, free-flowing material. As StormPRO is a flexible pipe and its strength comes from its interaction with the soil, placement of material in the haunch and side support zones is the most important part of the embedment process. Using the correct tools to haunch ensures the embedment material is pushed around the underside of the pipe, assisting with the pipe's integrity and overall system strength. Stabilizing sand or CLSM can also be used as a backfill material. Placing and compacting embedment material should be placed in the following manner to ensure 1. Uniform distribution and compaction of embedment material, especially under the haunches of the pipe. 2. The material relative compaction is consistent with design. 3. Pipe distortion is minimized. 4. The pipe is not damaged. And 5. The specified pipe alignment, level and grade is maintained. The overlay zone should be a minimum of 150 mm of embedment material above pipe. Compaction should be carried at the edges of the trench, avoiding direct contact at the top of the pipe area. It is recommended to use a whacker or a vibrating tool. In non-trafficable areas, the material obtained from excavation can usually be used to backfill the trench to the finished surface. In trafficable areas, refer to the road owner's specification for backfill, subbase and pavement materials, and compaction requirements. During construction, contractors will deal with different heights during the process. Short-term relates to construction loads and long-term relates to finished surface level and the loadings required during these periods. It is important to note the difference between construction heights and finished heights. Refer to the Vinidex StormPRO Installation Guide or AS NZS 2566.2 for further details and requirements.